Carbon monoxide has same electrons, or the ion that is isoelectronic with CO is isoelectronic will have equal number of electrons. So CO has 6 plus 8, 14 electrons. Cn minus, that is cyanide, will have 6 plus 7 plus 1 extra electron is equal to 14 electrons. So these two species are isoelectronic to each other. Option B is the correct answer.
Calcium acetate on heating under distillation gives A. Acetaldehyde and calcium oxide, B. Calcium carbonate and acetic acid, C. Acetone and calcium carbonate, and D. Calcium oxide and CO2. Now calcium acetate, which is given by the formula CrCOO twice Ca, on dry distillation will give the answer as RCOR plus CaCO3. So by this we know that dry distillation of calcium salts or fatty acids other than formic acid gives ketones. Therefore here the correct answer is acetone and calcium carbonate. The correct answer here is option C. Here is a given reaction, and we need to find out what are the byproducts of after the hydrolysis of this, and what is the end product B, that is A and B. Therefore let's look at the reaction now. CH triple bond CH plus H2O in the presence of H2SO4 and HgSO4 will give as CH3CHO. So here the A is equal to CH3CHO, which on further in the presence of H2 and Ni at a temperature of 300 degrees Celsius will give the product as CH3CH2OH, which is B. Therefore the correct answer here is CH3CHO and CH3CH2OH, which is option A. Among the given compounds, the most susceptible to nucleophilic attack at the carbonyl group is either MeCOCl, B MECHO, C MECOOMe, or D MECOOCOMe. Now, amongst aldehydes and acid derivatives, acid chloride, which is Cl, are the most susceptible to nucleophilic attack due to the strong -I effect and the weak +R effect of the Cl atom, that is the chlorine atom, as a result of which carbonyl carbon has the highest electron deficiency. Therefore the actual order is MECOCl is more than MECOOCOMe, MECOOMe, and MECHO. Therefore here the correct answer is MECOCl, which is option A. Compound has a vapor density of 29. On warming an aqueous solution of alkali, it gives a yellow precipitate. The compound is, here are the options. Now, let's first find the molecular weight of the compound. Now, the molecular weight M is equal to 2 into the vapor density, which is 29, which is 2 into 29, which is 58. Now, the molecular weight of CH3, CH2, CHO, which is option A, is 58. The molecular weight of CH3, CHOH, CH3, which is option B, is 60. The molecular weight of CH3, CO, CH3, which is option C, is 58. And the molecular weight of option D, which is CH3, CH2, COOH, is 74. Both option A and option C have a molecular weight of 58, but only aldehyde, that is CH3, CH2, CHO, on warming with aqueous alkali gives yellow precipitate. Therefore, here the correct answer is option A, CH3, CH2, CHO. The aldehyde which react with NaOH to produce an alcohol and sodium salt is HCHO, which is formaldehyde, CH3CHO, CH3CH2CHO, or CH3CH2CH2CHO. Now here the correct answer is formaldehyde. Formaldehyde and NaOH reacts to produce alcohol and sodium salt of an acid. The formula is 2HCHO plus NaOH on reaction gives HCH3OH, which is an alcohol, plus HCOONA, which is sodium formate, which is a sodium salt. Therefore here the correct answer is option A. Here are the given reaction. Now here we want to find the reactant A. Is it either acetone, acetaldehyde, propanaldehyde, or D, formaldehyde? Now, the answer is actually two molecules of acetone, the option A. Two molecules of acetone condenses in the presence of dry HCl gas to form methyl oxide. The answer here is the product here obtained is methyl oxide. The reaction is CH3C CH3 double bond O plus H2 CH C double bond O CH2 CH3 in the presence of HCl give the reaction as they give the product as methyl oxide. Therefore, here the correct answer is option A, acetone. Which one of the following undergoes reaction with 50% sodium hydroxide solution to give the corresponding alcohol and acid? A. Butanol, B. Benzaldehyde, C. Phenol, and D. Benzoic acid. Now, this is the form of a Cannizzaro reaction in which benzaldehyde will undergo Cannizzaro reaction or treatment with 50% NaOH, which is sodium hydroxide, to produce benzyl alcohol and benzoic acid, as it does not contain alpha hydrogen. Thus, formula is here. The reaction takes place is like this. Benzaldehyde on 50% of NaOH will undergo Cannizzalo's reaction to give the product as a benzyl alcohol and sodium benzoate. So therefore, here the correct answer is actually option B, benzaldehyde. The presence of a dilute base C6H5CHO and CH3CHO react together to give a product. The product is, here are the options. Now let's look at the reaction taking place. CHO, this is the reaction which takes place. Now in this reaction, H will go to O and C will be go to here. Therefore, in the presence of a base, this will be formed as the product form is COH. Double bond will break here and H will come here. OH, H, CH, H, CHO, which is known as. Now here the both the H will come, the H, OH and the H will combine to form a double bond, which will be given by this product. So the final product obtained will be CH double bond CH CHO, which is known as cinemaldehyde. Cinemaldehyde. Therefore, here the correct answer will be option D, C6H5CH double bond CH CHO. The reaction of an aldehyde with hydroxylamine gives a product which is called A. Amino hydroxide, B. Hydrazone, C. Semicarbazone, or D. Oxime. Now we'll look at the reaction. When an aldehyde reacts with a hydroxylamine which is H2NOH, it gives the answer as RCH double bond NOH, which is an oxime. Therefore, here you can all know that the correct answer is option D, oxime. The following would undergo aldol condensation: A. CCl3CHO, B. CH3C CH3 CH3 thrice C CHO, C CH3CH2CHO, or D HCHO. Now, what is aldol? The H, the hydrogen atom attached to the alpha carbon atoms, are called alpha hydrogen atoms. Now, aldehydes having alpha hydrogen atoms can participate in aldol condensation. That is the rule for aldol condensation. However, in option C, which is CH3, CH2, CHO, alpha carbon and the beta carbon also has the hydrogen attached. Therefore, this won't undergo aldol condensation. Therefore, the correct answer here is option C. When CH3COCH3 reacts with Cl2 and NOH, which of the following is formed? A. CHCl3, B. CCl4, C. CCl2H2, and D. CH3Cl. Now, let's look at the reaction happening between CH3COCH3 and Cl2. CH3COCH3 plus Cl2 NaOH gives the product as 2CHCl3 plus 2CH3COO and A plus HCl. Therefore, here the product formed will be CHCl3. Therefore, the correct answer here is option A. A Witting reaction with an aldehyde gives A. Ketone compound, B. A long chain fatty acid, C. Olefin compound, or D. Epoxide. Now, Witting reaction R affords an important and useful method for the synthesis of alkenes, which is also known as olefins, by the treatment of aldehydes or ketones with alkaline diphenyl phosphine pH3 PCr2, or simply known as phosphorane. Therefore, the Witting reaction with an aldehyde gives alkenes or olefins as the product. Therefore, the correct answer is option C, olefin compounds. Reaction of butanone with methyl magnesium bromide followed by hydrolysis gives. Here are the options. Now let's look at the reaction. Butanone, which is CH3CH2 C double bond O CH3 with methyl magnesium bromide MgBr, gives the product as CH3CH2 C O MgBr CH3, which on further hydrolysis gives two byproducts, which is MgBrOH and CH3CH2COH CH3, which is 2-methyl 2-butanol. Therefore, here the correct answer will be option A, 2-methyl 2-butanol. The following compounds is most reactive towards nucleophilic addition: A CH3CHO, B PHCOCH3, C PHCOPH, or D CH3COCH3. Now, in the nucleophilic addition reaction of carbonyl compounds, the order of the reactivity is HCH double bond O is more reactive than RCH double bond O is more reactive than RC double bond O. The lower reactivity of ketones over aldehydes is due to the plus I effect of the alkyl group. The aromatic aldehydes and ketones are less reactive than their aliphatic analogues. This is due to the plus R effect of the benzene ring. Now, from this information, it is clear that the increasing order nucleophilic addition reaction in the following compounds will be PHCOPH is more reactive than is less reactive actually than PHCOCH3 is less reactive than CH3COCH3 is less reactive than CH3CHO. Therefore, the most reactive towards nucleophilic addition is A, CH3CHO. Acetophenone, when reacted with a base C2H5O Na, yields a stable compound which has the structure. Here are the options of the structure. Now let's look at how the reaction takes place. Acetophenone, which is C6H5 C CH3 O negative plus CH3 C double bond O CH C6H5 in the presence of a base reacts to form a structure which is C6H5 C CH3 OH CH2 C double bond O C6H5. Now here water will go, this whole thing plus 1H forms water, so this will be removed and H2 minus H2O will be removed to form a product which have two benzene ring structures like this: CH3 double bond CH C double bond O and another benzene ring right here. Therefore, here this is the end product after when acetone reacts with a base C2H5O Na. Therefore, the correct answer here is option B. Acetaldehyde on treatment with dilute NaOH followed by heating gives. Here are the options. Now, let's look at how the reaction will take place. Acetaldehyde CH3CHO on treatment with dilute NaOH gives the product as CH3 CH CH2 CHO OH. Now, on heating, it will undergo aldol condensation to give the answer as CH3, CH, double bond CH, CHO plus H2O. Therefore, here the correct answer will be option C, CH3CH, double bond CH, CHO. Which compound is soluble in H2O? A. HCHO or B. CH3CHO, C. CH3CO, CH3 or D. all of them. Now H2O, the formula for H2O is H2O, water, which is H2O, which has a hydrogen bonding. Therefore, all the products which has an hydrogen bonding will have will be soluble in water. Therefore, here all the three products have a hydrogen bonding between them. Therefore, they will be soluble in water. Therefore, the correct answer is actually option D, all of them. Reaction. Now we need to find the answer of A. What is A? Is it primary alcohol, secondary alcohol, tertiary alcohol, or a ketone? Now let's look what happened with the reaction. Now CH3C double bond OH when reacts with CH3 MgBr, and when it goes hydrolysis at the same time, the product form will be CH3 C CH3 OH and H, which is a second degree alcohol. Therefore, here the correct answer is secondary alcohol, which is option B. Which gives lactic acid on hydrolysis after reacting with HCN? Is it either A. HCHO, B. CH3CHO, C. C6H5CHO, or D. CH3CO, CH3? The correct answer here is option B. CH3CHO. Since Let's look at how the reaction takes place. When CH3CHO is treated with HCN, it undergoes a reaction which gives the product as CH3, CH, OH, CN. And when it hydrolysis, it gives the product as CH3, CH, OH, COOH, which is also known as lactic acid. Therefore, here the correct answer will be option B. CH3CHO react with aqueous NaOH solution to form A. 3-hydroxybutanol, B. 2-hydroxybutanol, C. 4-hydroxybutanol, or D. 3-hydroxybutanol. Now, let's look at how the reaction will take place. 2-CH3CHO gives, in presence of dilute NaOH, gives the product as CH3CH, CH2CHO, OH, which is 3-hydroxybutanol. Butanol. Butanol. Therefore, here the correct answer is option A. Which one of the following compounds will undergo Cannizzaro reaction? A. Propanaldehyde, B. Benzaldehyde, C. Bromobenzene, or D. Acetaldehyde. Now, those aldehydes in which alpha atom is absent can participate in Cannizzaro reaction. So out of all the options, only benzaldehyde, which is C6H5CHO, has no alpha atoms, hydrogen atoms. Therefore, the correct answer here will be option B, benzaldehyde. Which of the following compounds will give positive test with Toluene's reagent? A. Acetamide, B. Acetaldehyde, C. Acetic acid, or D. Acetone. Now, Toluene's reagent is ammoniacal silver nitrate solution. Therefore, its reacting species is Ag+. It oxidizes aliphatic as well as aromatic aldehydes. Therefore, RCHO plus Ag plus undergoes redox reaction to form RCOOH plus Ag. Therefore, acetaldehydes are the correct answer, which is option B. Aldehydes are produced in atmosphere by A. Oxidation of secondary alcohols, B. Reduction of alkenes, C. Reduction of oxygen atoms with hydrocarbons, or D. Reaction of oxygen atoms with ozone. Now, aldehydes are compound containing C, H, and O. In general, the structure of an aldehyde is RCHO. So hydrocarbons react with atmospheric oxygen to give aldehydes. Therefore, here the correct answer is option C, reaction of oxygen atoms with hydrocarbons. Which one of the following gives iodoform test? A. Formaldehyde, B. Ethyl alcohol, C. Benzyl alcohol, and D. Benzaldehyde. Now the compound having alpha hydrogen atoms will give iodoform test positive. Now ethyl alcohol and secondary alcohols also give a positive iodoform test because by the action of halogens in alkaline medium, they are oxidized to acetaldehyde and methyl ketones respectively. Here is one example to prove that CH3CH2OH is a secondary alcohol which in the presence of I2 and NaOH undergoes reduction and forms CH3CHO, which is reduced to an aldehydes. Now further on reduction it forms Cl3CHO, which on further oxidation by H2O it forms HCOONA and CHI3. Therefore, here the correct answer is B. Ethyl alcohol. The reagent used for the separation of acetaldehyde from acetophenone is A. NaHSO3, B. C6H5NHNH2, C. NH2OH, and D. NaOHI2. Now, here the correct answer is actually NaHSO3. It gives the addition reaction with aldehydes and aliphatic ketones. Now, acetophenone is the aromatic ketone, so it does not give addition product with NaHSO4. However, aldehyde forms the addition product with NaHSO3, which on treatment with acid or base give again aldehyde. Let's look at one example. Now, RCHO plus HSO3Na gives RCOH H and SO3Na, which on further oxidation H2 or OH minus gives aldehyde again. Therefore, here the correct answer is option A. General order of reactivity of carbonyl compounds for nucleophilic addition reaction is, here are the options. Now, the size of the alkyl group causes hindrance to attacking group. As the number and the size of the alkyl group increases, the hindrance to the attack of the nucleophile also increases. Thus, the reactivity follows the order CH2 double bond O is more than an aldehyde is more than an aromatic aldehyde is more than R2 C double bond O, a ketone, is more than an aromatic ketone. Therefore, here the correct answer is option A. Benzophenone can be converted into benzene using A. Fused alkali, B. Anhydrous AlCl3, C. Sodium amalgam in water, and D. Acidified dichromate. Now let's look how the reaction takes place. C6H5CO C6H5, which is benzophenone, on reaction with KOH will have a fusion reaction and will give the answer product as C6H6 plus C6H5COOK, which is benzene. So therefore the correct answer here is option A, fused alkali. Acetaldehyde is heated with filling solution. It gives a red precipitate of, here are the options. Now let's look at how the reaction takes place. So acetaldehyde plus 2Cu plus 2 plus 5OH minus, which combines to form a filling solution, undergoes a reaction and forms a product as CH3COO minus plus Cu2O plus 3H2O, where Cu2O will form a red precipitate. Therefore, here the correct answer will be option C, Cu2O. Compound containing only carbon, hydrogen and oxygen has a molecular weight of 44 on complete oxidation. It is converted into a compound of molecular weight 60. The original compound is A, an aldehyde, B, an acid, C, an alcohol, and D, an ether. Now, on complete oxidation, the obtained compound shows increment in the molecular weight only 16. Therefore, it means only one oxygen atom is added here. This condition is fulfilled by only aldehyde, which on oxidation gives acid. Therefore, an aldehyde which undergoes oxidation gives an acid. Hence, the original compound must be CH3CHO, which on oxidation gives CH3COO, H, because CH3 aldehyde has a molecular weight of 44 and the resulting product has a molecular weight of 60. Therefore, the correct answer here is option A.